All right, thank you so much for joining us today, and I'm so excited because this is the last video towards the preparation of our final exams, and we have 37 questions on integration. So stay here and let's go through together. Now, the first question wants us to integrate sine of 2x plus 3. Now, some of them I will use shortcut because you've learned how to do integration so that we can solve them very fast. So here the shortcut is going to be integrate sine. What are you going to get? You are going to get minus cos 2x plus 3. I said in some of my videos, and I said anytime you are dealing with integration goes with what? Division. So we are going to divide this one by differentiating what is inside, and this is going to give us 2 plus c. And we see that the answer is right here. Sometimes when you are dealing with multiple choice questions, pay attention to the options, right? Because sometimes you might get the answer right, but because you are time bound, you are trying to circle and then you choose the one which is not supposed to be the answer. So when you are done solving, try to also circle the right answer that you had. Let's look at question 2. So question 2, we want to integrate this, right? So we want to integrate 0 to pi over 4 times squared x dx. I don't know, when I'm integrating times squared x, I don't know the exact integration. So this one you might think of maybe integration by substitution, but I have a better way. What's the better way here? We know that 1 plus tan squared of x is equal to secant squared of x. So I can make tan squared a subject here and have tan squared of x to be equal to secant squared of x minus 1. So I'm going to replace this one by this. So let's see what we are going to get from here. This is the same as integration from 0 to pi on 4. Then I'm going to have secant squared x minus 1 or the x. So this trig identity is very useful here. And now let's do the integration. So I'll integrate sec squared. Remember the function that when we differentiate, we get sec squared, right? That is tan x. So this is going to give us tan of x minus, when I integrate a constant, I multiply by x. So this is going to give us x, then from 0 to pi on 4. So you see that I didn't go through the integration by part, right? Because of this identity that I have here. So that is objective for you. You try to find better ways to solve the question, right? So that's basically what you try to do. Minus, when you plug in 0, tan of x, tan of 0 minus 0. So what are we going to get here? What is tan of pi on 4? That is 1 minus pi on 4. And tan of 0 is 0. So everything there goes to 0. And this is going to give us minus pi on 4 plus 1. So let's see if we have minus pi on 4 minus plus 1 here. Yes, we have it there. So that is basically how you can do integration. So try and pick some shortcuts and then you just see how you can do your things. This one like this, I can pick shortcuts to just do it straight, but let's see how we can do this. Minus 2 to 2 x to the power 7 plus k dx is equal to 16. This one I can use shortcut to just know the answer here. How am I going to know this? Here, the idea is that I can use the idea of odd and even functions. Since this is minus 2 and this is 2, this is symmetric. So since this is odd, this one will go to 0. When I do it, this one will go to 0. So it means that I just need to just integrate this and have kx from minus 2 to 2 is equal to 16. And this is going to give me k of 2 minus k of minus 2, which is equal to 16. And this is going to give me 2k plus 2k is equal to 16. 4k is equal to 16. And k is equal to 4 when I divide through by 16. You say like, how? Okay, so let me now go through the whole process for you to see. So that is basically what you just need to do. When you know how to do the integration, when you are doing these objective questions, you save time, right? Now, let me go through, assuming that I don't know that this one is equal to 0, and let's do this. When I integrate x to the power 7, I'm going to have x to the power 8 divided by 8 plus, when I integrate k, I'm going to have kx from -2 to 2 is equal to 16. And see what is going to happen here. I'll plug in 2. So I'm going to have 2 to the power 8 divided by 8 plus k times 2 minus 2 to the power 8 divided by 8 plus k minus 2. This is equal to 16, right? It's equal to 16. Let's maintain like that. I'll not simplify this. I'll just maintain it like that. Plus 2k minus, when I multiply through the minus, since this one is even, this one becomes positive. So I'm still going to have 8 to the power 2 to the power 8 divided by this. And then minus and the minus here become positive. So I'm going to have plus 2k, which is equal to 16. So you see that this will cancel this. Where from this and this? This and this is coming from this function that we have here. So that's the reason why I saw that this one will go to 0, because this is odd. And when I integrate, I'm going to have it even because the function is symmetric. I do only this when it is what? Symmetric. The same value here, but it's just differed by minus. Then I use the idea. So anytime you are doing integration and you see that the integration here is odd, like an odd number here, it will go to 0 because of the symmetric aspect that we have here. Let's look at question 4. Let's look at question 4. So question 4 here is basically talking about the fundamental theorem of calculus, right? So if I have AB of f of x, then this is basically equal to big F of x from A to B. Then when you plug in the limit, you get this minus that. The idea is that f prime here, big F prime here is equal to small f of x. So if I want to show you how it came by, then this is the same as big F prime of x dx is equal to that. Because we are saying that big F prime is equal to small f. So I replace this one by big F. Then differentiation will cancel integration, right? So I'm going to have the big F, then I plug them in. So this is going to give me D, right? So I'm going to have D here. Good. Let's look at question 5. Let's look at question 5. So question 5 is here. Now look at this. This is not symmetric. So don't use the idea that we used from the first one, saying that maybe this one is this one is that. No, we are not going to do that. So now let's do integration here. We are saying that this is equal to 5 and we want to find this. So let's see how we can solve this. Now we have given 1 minus c, 2 minus c, f of x dx. So what can we do here? What can we do here? Let's see. Before we solve this one, what we can do here is we can try to manipulate this 1 to 2, f of c minus this, dx is equal to 5. Let's try and then, do something here so that we can do some substitution. Now, this one, when we are using the fundamental theorem, we are going to have, when I integrate this, I'm going to have the big F. So big F of x minus c from 1 to 2 should be equal to 5. And then when I plug in 2 is for x, I'm going to have big F of 2 minus c minus big F of 1 minus c, which is equal to 5. So let's put this one down here so that we can use it to do substitution. Now let's look at how we can also solve this one too here. Now this, using the fundamental theorem, I'm going to have big F of c, which is from 1 minus c, 2 minus c, and this is the same as big F 2 minus c minus big F 1 minus c, and you see that this is basically the same as f, which is equal to 5. So this is equal to 5, and the answer is going to be 5. So you see that what we are just doing here is we are doing something like this minus c here is what we are just bringing it here and here from here. So this one, without even solving, you should be able to know that this is going to be equal to 5 here. Let's look at question 6. Question 6. Let's look at question 6. So we want to integrate minus pi over 4, 0 secant tan. the x. So for me, I always say that if you know how to do differentiation, basically the integration becomes bonus. Now I know that when I differentiate secant, I get secant tan. So it means that when I integrate this, I need to get secant. So this is just going to give us secant of x, then pi over 4 to 0 minus here. So that's basically the idea here. So now let's see what we can do here. Let's just do substitution. Now secant is the same as 1 over cos of x, so that we can do it proper. Plug in 0, 1 divided by cos of 0 minus 1 divided by cos of minus pi on 4. Now what is cos 0? Cos 0 is 1 minus what is cos of minus pi on 4? That is 1 divided by square root of 2. So this is going to give us 1 minus square root of 2. So this is what we are going to get from this. So 1 minus square root of 2. That is right here. Now let's look at question 7. Question 7. So this one, we need to use integration by substitution. So I'm going to choose my u to be equal to the cotangent of y. Cotangent of y. The idea is that when I differentiate cotangent of y, I'm going to have this one here. So that's the best choice for me. So I'll choose, let's say, u to be equal to cotangent of y. So that when I differentiate u with respect to y, I'm going to have minus cosecant squared y. Then I'll make dy the subject. So I'm going to have this squared y dy. So dy will be equal to du divided by cosecant of y. So now let's do substitution and see what we are going to get from here. So we are going to have something like this. Integration square root of cotangent of y, cosecant squared of y dy to be equal to, now this is equal to u. So I'm going to have square root of u times secant squared y times, now dy is the same as minus du divided by cosecant squared y, so that this will cancel this. So I'm going to have minus out u to the power 1 over 2, because square root of u is the same as this, du. Now let's do the integration now. Minus, this is going to be plus 1, so 1 divided by 2 plus 1, which is going to give us 3 on 2. So let me just write it, 3 on 2 divided by 3 on 2 plus c. Now let's try and do substitution. So this is going to give us minus 2 on 3 because of 1 divided by this. And then this is going to give us u 3 all to the power 1 over 2. So I can write this one too as this. Because of the solution, that's the reason why I want to do it this way. And then look at the solution here. Now what is u? U is equal to this. So I'll bring it in and have minus 2 on 3 cotangent cube y 1 over 2 plus c. And then this is going to give us minus 2 on 3 square root of cotangent cube y plus c. So that's what we are going to get from the function. So minus 2 on 3 minus 2 on 3. So yeah, minus 2 on 3 is this one. So here, if you don't pay attention, you might even choose this one, but this one is 3 on 2. So always pay attention to whenever you are choosing your final results too as well. Now let's look at this question here. Let's look at this question here. Now this question here, there's no need for me to solve because I know that the answer is going to be 0. Why? Because I have integration from minus pi on 2 to pi on 2. This is sine 2x. divided by 1 plus cos x dx. Now, this function here, sine is an odd function. And since it is an odd function, this one becomes 0, and 0 divided by this will be 0. So this will be equal to 0. If you want to try solving it, you can use integration by, let me say, substitution. So let me do that one for you so that you can just do that. So you can use integration by substitution. You can do something like this. Let me say u to be equal to, let's say, cos s, or u to be equal to 1 plus cos s. Yeah, so you can do something like that. And then you solve it, and you see that you go through a long process and you are still going to get a 0 from there. Now let's look at question 9. Question 9. Okay, so now question 9, we can do integration by substitution. So I will let u to be equal to ln of x, and du over dx will be equal to 1 over x, and this implies that dx is equal to x du. So integration natural log of x divided by x dx now will be equal to u divided by x times x du. So this is u, and then dx is equal to this. So it means that this will cancel this, and I'm going to have integration u du, and when I integrate u, I'm going to have u squared divided by 2 plus c. Now u is the natural log of x, so I'm going to have natural log of x all squared divided by 2 plus c. So that's what I'm going to get, and that's what I have here. Let's look at question 10. What can we do with question 10? Now, question 10, we can do something like integration by substitution, right? So I'm going to let u to be equal to 5x minus 1, and then du over dx will be equal to 5. When I differentiate this one here, this implies that dx is equal to du over 5. Now let's just plug them in and see what we can do here. So integration from 2 to 10 of 3 divided by square root of 5x minus 1 dx will now be equal to 2, 10, then 3 divided by square root of u, because now this is equal to u, and then dx is equal to this. So I'm going to have times du over 5. Here, you see that I didn't change the limit. So after the integration, I need to do backward substitution. If you want to change the limit, then you can say that if u is equal to this, you plug in 2. So this one is going to be 8. You plug in 10, and this is going to be 49. And you are going to get the same results at the end of the day. So now let's do the integration and see what we are going to get. This is going to be 3 divided by 5, 2 to 10. This is the same as 1 divided by u to the power 1 over 2 du. And I can write this one as 3 divided by 5, 2 to 10. This is u minus 1 over 2 du. And then now the integration will be 5. When I integrate this, I'm going to add plus 1. So I'm going to have u to the power 1 over 2 divided by 1 over 2 from 2 to 10. But don't forget, you've not changed the limit. So we need to do substitution by u, which is 5x minus 1. Now this is 1 divided by this, so this is going to be times 2. So I'm going to have it to be 3 over 5 times 2. Then u is 5x plus 1 minus 1 rather, all to the power 1 over 2 from 2 to 10. And then this is going to give us 6 divided by 5. Then 5x minus 1, 1 over 2 from 2 to 10. So what I can do here is just do substitution, and let's see what we are going to get at the end of the day. Plug in 10. We are going to have 6 divided by 5, big bracket. Plug in 10 here. When I plug in 10, this is going to be 50 minus 1. This is going to be 49. So 49 to the power 1 over 2 minus plug in 2. This is going to give us 9. So this is going to be 9, 1 over 2, this. Now 6 over 5. This is the same as square root of 49, which is going to give us 7. This is also the same as square root of 9, which is going to give us 3. So this is going to give us 6 over 5 times 4. And this is going to give us 24 divided by 5. That's what we are going to get from there. 24 divided by 5 is right here. Don't worry, I'll leave you some to do very soon. So this one too, we are going to use integration by substitution. So I'll leave this one for you to solve, but I'll just give you a hint. Let u to be equal to 2x cubed plus 2, and then use that one to solve and leave your answer in the comment section. Let's look at question 12. So question 12 is so interesting. 1 divided by cos x, cot x dx. This is the same as, I can write this one as 1 divided by cos s times 1 divided by cot x dx. Now 1 over cos s is the same as secant x, and then 1 over cotangent x is the same as tangent x dx. And then when I integrate this, I'm going to have sec x plus c. Because when I differentiate this, I'm going to get this. That's what I'm going to get from here. So I'm going to have this. So plus k, make it this one k. Let's look at this question here. Should I leave you this question to also do it? Yeah, so this one is pretty much straightforward. So do it and leave your answer in the comments section. Let's look at question 14. So question 14, we want to find dy over dx plus c from this. So this one means they've integrated the function 1, right? So dy over dx, or let me just write it this way, d squared y divided by x squared is equal to 10 minus 3x. The function has been differentiated 2 times, and we want to go to just differentiated just once. So we need to integrate this with respect to x and integrate this one to with respect to x. So when I integrate this one 1, I'm going to have dy over dx to be equal to, now integrate 10, you're going to get 10x minus integrate this, and you're going to have 3x squared divided by 2 plus c. So that's what we are going to get. Let's see if we have the answer there. Is this one right? No. It's not right. This is also not right. Because this one, when I want to divide, this one should be 20 here. Yeah, so there is no answer from this. This one was almost right, but I don't know if there was a typing mistake from there, I'm sure. So this one, the answer is mostly to be like this one. So this one, we just need to differentiate this one once and get what we have here. Now let's see what we are going to get from this. Let me try and see if there is a manipulation aspect that we need to do from here. No, we cannot do any manipulation here. Okay. Okay, so that's all. Now let's move to question 15. Question 15, right? So question 15, we want to integrate secant squared 5x dx. I will use the shortcut. First, remember that when I integrate secant squared, I'm going to get tangent, right? So this is going to give us tangent 5x. Then I'm going to divide this by differentiating what is inside, which is going to give us 5 plus c. That's very simple, right? But if you cannot remember this, what you just need to do here is you need to write this one as this. You need to let u to be equal to 5x, and then du will be equal to 5 dx, or let me see, dx will be equal to this. And then what you are going to do is you are going to have secant squared u times du over 5, and this will be 1 over 5 secant squared u du. But when I integrate this, I'm going to get the tan, so I'm going to have 1 over 5 tan of u plus c, but u is equal to this, and you get the same thing here. So knowing the shortcut to go through is also very important. Very, very important. Now let me guide you through this, then maybe I'll stop somewhere. So 1 to 8, 1 divided by x to the power 1 over 2 dx. This one, I can write this one as 1 to 8, and then this one can be written as x to the power minus 1 over 2 dx. So that's basically what you just need to do. And then now you integrate this, you add plus 1. So this is going to be 1 over 2 divided by 1 over 2 from 1 to 8. And this is the same as 2x to the power 1 over 2 from 1 to 8. Plug in 8, 2, 8 to the power 1 over 2 minus 2, 1, this. So square root of 8 is the same as 2 root 2. So this is going to give us 4 root 2. And then this is going to give us minus 2. So let's see if we have answer there. Okay, we don't have any answer there. So we just move. Now let's do this one too and see. So this cubic root of x squared dx, this is the same as integration x squared all to the power 1 over 3 because of the cubic root. And this is the same as 2 divided by this dx. And then I integrate this and I'm going to have plus 1. So this is going to give us x to the power 5 on 3 divided by 5 on 3 plus c. And this is the same as 3 divided by 5, 5 over 3 plus c. So this is what I'm going to get at the end of the day, which is going to give us something like d right here. You're going to have something like d right here. Oh, I think this question, I just repeated it, right? I remember we solving this question here, and then we having something like this. Yeah, we've solved this particular question here. Sorry, question was repeated. Let's look at this question here. Nice question. Nice one. We want to find f of x from this. So basically what we just want to do is we want to integrate this, right? And the answer that we are going to get plus c. So we pick this one as the function. So 2x dx, this is equal to, now we want to integrate this. This is constant base. So I'll maintain the function. I will divide it by the derivative of what is on the top, which is going to be 1 times ln of the base, which is going to give us 2 plus c. So this is the same as 2x divided by ln 2 plus c. So when I compare this to this, I have plus c plus c. So my f of x is equal to this, and this is going to give us c, which is right here. The c, because they are using log, so I can change this one. Instead of ln, I can also use log as well. So this is objective, so log is there. Now let's look at 20. So 20, we want to find k. So I think we've done some question like this before. So this is integrating from 0 to 1, x to the power 3 plus k dx is equal to 10, right? So this is going to give us, integrate x to the power 3 is going to give us this. When I integrate k, I'm going to have this from 0 to 1 is equal to 10. Now this one, we cannot use the idea of symmetric because this is 0 and this is 1. So this is going to be 1 divided by 4. When I plug in 1 here and 1 here, I'm going to have this minus, when I plug in 0 here, 0 here, this one was going to be 0, equal to 10. So k will be equal to 10 minus 1 over 4. And this is going to give us 39 divided by 4. 39 divided by 4 is going to give us a here. Now let's look at this question here. So this one too, we are going to use integration by substitution. So I'll show you, then you solve it. You leave your answer in the comment section. So you let u to be equal to x to the power 5 minus 9, right? and then you find du over dx to have 5x to the power 4, and then here you can say that du is okay. So let me solve. This one is this dx. So my integration 5, this square root of 5x x to the power 5 minus 9 dx now will be equal to integration. Now this and this combined is here, so I can replace this one by this. So I'm going to have 1 divided by square root of u, because this one is this, right? And then times du, because this combined by this is equal to u, which is here. So it's going to be left 1 divided by this. So this is going to be 1 divided by u1 over 2 du. Then I can write this one as u to the power minus 1 over 2 du. And then integrating this is going to give us u1 over 2 divided by 1 over 2 du. And this is the same as, sorry, there's no du again, plus c. And then 2u1 over 2. But what is u? U is 5x to the power 5 minus 9, 1 over 2 plus c plus c. So that's basically what we are going to get here. And then I can write this one as 2 square root of x to the power 5 minus 9 plus c. And let's see. Okay, we have it here. We are almost done. Let's look at 22. Good. So now look at this one here. Somebody's like going to ask, now you see that this is symmetric, right? But here we are not going to use the idea that this one is odd, so this one should go to 0, so that it will be left with only this. The idea here is that because this we have absolute here, we cannot use the same idea. If this one was just like this, we are going to say that this is odd, so this one will go to 0, so it will be left with this one only. So here what we just need to do is we are going to split the integration into 2. How am I going to do that? Let's see. Integration minus 2 to absolute of x minus 1 dx. Before we split the integration into 2, this is what is going to happen here. We are going to start from the lower limit, which is minus 2 here, up to the upper limit, which is 2 here. But we need some interval here, which I'm going to show you. Now, for us to get the interval here and the interval here, we need to pick the one in the bracket here, x minus 1, and set it to 0, and find for x. So x will be equal to 1. So it means that here I'm going to put 1 here and 1 here. Now when I'm done, now this absolute here, we know that absolute of x minus 1 is the same as plus or minus x minus 1. Meaning that we have one function which is minus x minus 1, and we have another function which is x minus 1 as positive. So now always the minus 1 will pick the first interval, and then the positive one will pick the second interval, right? Because the minus 1 is within the first interval that we are going to pick with the lower limit. So this is going to be minus x minus 1 dx, and then the last one will be x minus 1 dx. So this is how you can split the integration to solve. So now let's try and solve it. So now this one becomes easy for us. So now when I multiply the minus, I'm going to have, or I can just factor the minus out. So I'm going to have minus out. When I integrate x, I'm going to have x squared divided by 2 minus x from minus 2 to 1. And then plus, when I integrate this, I have x squared divided by 2 minus x from 1 to 2. So let's do that. Minus out, plug in 1, we are going to have 1 over 2 minus 1, minus plug in minus 2, and we are going to have 4 divided by 2 plus 2. So this is for the first integration. Plus plug in 2, you are going to have 4 divided by 2 minus 2, plug in 1, and we are going to have minus 1 over 2 minus 1. So let's try and simplify it. Minus, this is going to give us minus 1 over 2. This is going to give us 4, so minus 4, plus this is going to give us, oh, is this one supposed to be minus? I think so. Okay, it's supposed to be plus because this is minus 2, so that's right. This is going to give us 0 because 4 and 2 is going to give us 2. Then minus, this is going to give us minus 1 over 2. So minus what is minus, this is going to give us minus 9 divided by 2. Then minus minus here will be positive, so plus 1 over 2. This is going to give us 9 over 2 plus 1 over 2, and this is going to be 10 divided by 2, and this is 5. So we are going to get 5 from here. No options, none of these, so this is okay. Let's look at 23. Now with 23, we want to now look at this. So how can we do this? The same idea, we can let u to be equal to the natural log of x squared. So du over dx will be equal to 1 divided by x squared times 2x. So 1 divided by what is inside the parentheses times when you differentiate what is inside the parentheses. 1 of the x will cancel 1 of the x here. So this will be now left with x 2 over x. So du will be equal to 2 over x dx. Is that right? Yes. And then this implies that dx is equal to x du divided by 2. So let's try and then plug them in and see what we are going to get from here. So integration x squared divided by x dx will be now equal to, this is equal to u. So I'm going to have u divided by x times x du over 2, because dx is equal to this. Now this will cancel this, so I'm going to have u over 2 du. I can factor 1 over 2 out and have u du. This is 1 over 2 u squared divided by 2 plus c. This is u squared divided by 4 plus c. U is the natural log of x squared. So I'm going to have natural log of x squared all squared divided by 4 plus c. So that's what I'm going to get. And I have it right here. Yes, that's A. Now, I think we've done something like this, but the other one that we did was 2 here. So just give you the hint. 1 over x to the power 1 over 3 dx can be written as 1 to 8 x to the power minus 1 over 3 dx. So try this and leave your answer in the comment section. Let's look at 25. Let's look at 25. Let's look at 25. We have if d over dx of f of x is equal to gen of x, then the antiderivative of gen of x, or the entire derivative of gen of x is. So what we mean here is integration of gen of x is equal to what? So that's the question. But we know that gen of x is equal to this. So we can do substitution. D over dx f of x dx, because we know that gen of x is equal to this. So that's what we have here. Now this d here, this here will cancel this will cancel this. So this is going to give us f of x. So this is just f of x right here that we are going to have. So that's what we are going to get from there. Now let's look at this here. If u is equal to this, then what can we do here? What can we do here? Let's try and see. Now we are trying to change everything to u. So if u is equal to square root of x minus 1, then what we can do here is, this implies that I can square both sides and have u squared is equal to x minus 1. And this implies that x is equal to u squared plus 1. Now the limit too, we need to change it, or they didn't change the limit. Okay, they didn't change the limit, because when I plug in 0 here, it's not going to work. So the limit was not changed. So from 0 to 3, dx over x square root of x minus 1 dx will be the same as from 0 to 3. Now I should be able to differentiate x. So let's do the differentiation here. Dx over du will be equal to 2x and dx will be equal to 2x du. Is that right? Oh, this one's supposed to be u. So u. Good. So let's go. Dx here is the same as 2u du divided by x. What is x? We know that x here is the same as this. So I'm going to have u squared plus 1 times this. This here is equal to u. So I'm going to have times u. We have something like that there. Okay, we have something like that. Now this u will cancel this u. So I'm going to have 0 to 3 du over u squared plus 1. U squared plus 1, which is going to give us, okay, there is 2 also in front of this. So I think it's supposed to be a. Yes, it's going to give us the a. A here. Good. That's what we are going to get from there. Now let's look at this. I love this question. This will help us to apply the fundamental theorem, right? So let's apply the fundamental theorem to see what we are going to get. Now, minus 2 to 2 f of x dx plus 2 minus 1 f of x dx minus f of x dx. Here we cannot use the idea of symmetric because we don't know this function whether it is odd or it is even, right? So we just need to apply the fundamental theorem. So this is going to give us fundamental theorem. This is going to give us, this one here is going to give us a big F from minus 2 to 2 plus a big F from 2 to minus 1 minus a big F from minus 2 to 1. So let's do substitution. This is big F of 2 minus big F of minus 2 plus big F of minus 1 minus big F of 2 minus big F of 1 minus big F of minus 2. So let's try and simplify this. Big F of 2 minus big F of minus 2 plus minus 1 minus big F of 2. Multiply 2 by minus and have this plus this. So you see that we can cancel some of the functions out. This and this will cancel. And then this and this too will cancel. So it's going to be left with big F of minus 1 minus big F of 1. And this is the same as big F of x from 1 to minus 1. Yes. And let me look at the answer given. And we can write this one too as integration from 1 to minus 1 f of x dx. So this is going to give us, I think, d, right? Integration from 1 to minus 1. And then we have dx. Yeah. So that's what we are going to get for 27. That's what we are going to get for 27. So the question is saying that if we have C in between A and B, then this is the same as this, true or false. True or false. Okay, so if this one is in between this and this, then integration A to B of f of x, this one can be written as A to C. So from A to C, f of x plus from C to B, f of x dx, not minus. So this is true, but this is false. So we are going to choose the B to be the final result for this one. Now let's look at this. Let's look at it. Find the area under the curve of this. We want to find the area under the curve. So what is the area under the curve here? Here we know that the function is like kind of symmetric, right? So we are going to do something like this. That's what I'm going to show you here. So we are going to have something like, let me just do it like this. From minus 2 to 2 of gen of x dx. This is symmetric. So what we are going to do here is we are going to pick the function and set it to 0. So we are assuming that this is having absolute because it's cubic, right? So x to the power 3 absolute. So I'm going to pick what is inside the absolute and set it to 0. And this x is going to be 0. So it means that I can divide this integration into 2 and have from -2 to 2. Sorry, from minus this one to 0, a function, and then another plus another function from 0 to 2. So now what will be the function here? Now remember I said the function here is going to be the minus aspect of this absolute value here. So this is going to give us minus x cubed and then x cubed. So I'm going to pick the minus aspect here, and I'm going to maintain the aspect here. If I don't use this, the answer might look like it's going to be 0, but it is not 0. Because if I integrate it from -2 to this is an odd function and it will go to 0. But this is area under curve, so we need to split it into 2 like this and then solve. So let's see what we are going to get from here. When I integrate x to the power 3, I'm going to have -4/4 from -2 to 0 plus 4/4 from 0 to 2. Plug them in, minus, plug in 0. When you plug in 0, you are going to get 0. So it's going to be 0 minus, plug in 2, and you are going to have -2 to the power 4 divided by 4 plus, plug in 2 here, 2 to the power 4 divided by 4 minus, plug in 0, and you get 0. So what is 2 to the power 4? This is going to give us -16/4 plus another 16/4 here. So this is going to give us this is going to be 4, -4 plus 4. And this is going to be +4 plus 4, and this is going to give us 8. So we are going to have D here. So pay attention to the questions whenever you are doing them. Now let's look at this question. Find the area. So we want to find the area which is bounded by this curve here. So what we are going to do is, sometimes you need to look at how you are going to sketch these functions. It's very important to do some sketching, right? So here I'm going to go with y. So y is equal to x squared, and then x is equal to y squared. Here, when I make y the subject, I'm going to have y is equal to square root of x, right? So let's find the intercept so that we can know where we are going to integrate the function to. So I'm going to have this is equal to this. So I'm going to have something like x squared is equal to square root of x. I'll square both sides. Squared. So I'm going to have x to the power 4 is equal to x. And I'm going to have x to the power 4 minus x is equal to 0. X out, x to the power 3 minus 1 is equal to 0. So this implies that x is equal to 0 and x to the power 3 minus 1 is equal to 0. X to the power 3 is equal to 1, and then x is equal to 1. So the point that I'm going to get from here is going to be 0 and 1. So it means that the interval for integration is going to be 0, x less than 1. So that's the integration point that we are going to use. So let me shift this one to the side. Now we need to know how we are going to do the integration, because we know that the area is going to be from 0 to 1. Now the function above minus the function below, all squared dx. So now the question is, which function is above and which function is below? That's basically what we just need to know. So first you need to know the original sketch of this. So if y is equal to x squared and y is equal to square root of this, we know that x squared is of this form, right? And this y squared here is going to be something like this, right? If we are talking about the positive side, then this one is going to be something like this. So this is square root of x and this is x squared. So which one is above? You can see that this one is above and this one is below. So it means that this now is going to be integration from 0 to 1. Square root of x is the same as x to the power 1 over 2 minus x squared. Or no, I think this one we don't need to square it. It's just function above minus function below dx. So that's what we are going to get. And we can go ahead to integrate. So integrate this and have 3 on 2 divided by 3 on 2 minus this divided by this from 0 to 1. So plug in 1 here, you are going to get 1. So this is going to be 1 divided by 3 on 2. Plug in 1, you have 1. Plug in 0 and everything goes to 0. Now this is the same as 2 on 3 minus 1 on 3. And this is going to give us 1 divided by 3. So that's what you are going to get. So it takes a lot of work to do this. Now let's look at this one too as well. So the same idea, for us to find the area bounded by these functions, we need to solve it simultaneously to get the intervals, right? So what can we do? We know that x is equal to this, and then x is also equal to this. So we can say that if x is equal to minus y squared plus 10, and x is equal to y squared. Okay, so I think this one's supposed to be x is equal to y minus 2 squared. I think so. This was supposed to be rather y minus 2 squared. Yes. So that was my bad from there. So this one's supposed to be that. So that now we can have x to be equal to y minus 2 squared. Good. So it means that we are going to have minus y squared plus 10 to be equal to y minus 2 squared. Good. So this is right. Then let's expand this. This is y squared minus 4y plus 4 minus y squared plus 10. Group like terms. This is going to be 2y squared minus 4y minus 6 is equal to 0. So I move this one here, making it 2. This one is already here. Moving this one become minus and give us minus 6. And then we just do factorization here. So you can divide 2 by 2 and have y squared minus 2y minus 3 is equal to 0. And then the factors of this is going to give us y squared plus y minus 3y minus 3 is equal to 0. So the one with the red, pull y out and have this. The one with the green, pull minus 3 out and have this. So this is going to give us y plus 1, y minus 3 is equal to 0. Y plus 1 is equal to 0, y is equal to 1. It's equal to 0, y is equal to 3. So the interval that we are going to integrate within is 1 less than or equal to y less than or equal to 3. Now the question now we need to ask is, now the function given to us, which one is going to be up and which one is going to be below, right? Because we have two functions here. We have x is equal to minus y squared plus 10 and x is equal to y minus 2 squared. So which one is going to be below, which one is going to be above? Remember, this is x, right? This is x. So here, when we are dealing with the function to be like this, we are thinking that the function, since we are going to this way, if I have something like this, which one is above? This and this, which one is going to be above? We need to think on the y-axis, not on the x-axis. So that's basically what we are going to do here. So here, the area will be equal to integrating from, okay, this one's supposed to be minus 1. Integrating from minus 1 to 3. Now, this is going to be the below one. So minus y squared plus 10 minus y squared minus 2 all squared dx. So let's do this one and see what we are going to get. Minus y squared plus 10 minus, we've already expanded this and we had y squared minus 4y plus 4. This one should be dy. Integration from minus 1 to 3. This is minus y squared plus 10 minus y squared plus 4y minus 4. Good. So let's combine them and have minus 2y squared plus y4 plus 6 dy. So let's see what we are going to get for the integration. this is going to be minus 2y cubed divided by 3 plus this is going to be 4y squared divided by 2 plus 6y from minus 1 to 3. 4 divided by 2 is going to give us 2, so we can write this one as 2y squared. Plug in 3 and minus 1, so 3 inside is going to give us minus 2, 3 cubed divided by 3 plus 2 times plus 6 minus, plug in minus 1, minus 1 cubed divided by 3 plus 2 times minus 1 squared plus 6 times minus 1. So this is going to give us 27 divided by 3 is going to give us 9. So this is minus 2 times 9 plus this is going to give us 2 times 9, 3 squared. Then 6 times 3 is 18. Minus this is going to give us minus 1 times this is going to give us 2 on 3 rather. Then this is going to give us plus 2 and this is going to give us minus 6. So minus 18 plus 18 plus 18 minus, when I solve everything in the bracket here, I'm going to have something like, let me see, 10 divided by 3 minus. So this will cancel this, so 18 plus 10 divided by 3, because of this is minus. So do this and get 64 over 3. 64 over 3. So let's see if we have 64 over 3 here. Okay, so this is C. Now let's see if this is true or false. Now if I have this, then this can be written as this. Let's see if it is true. Now the first question that you need to ask is, how is this being performed? That we are saying that this is true or false. I think we've done this question and we said it is false, right? But let's see how things are being done here. Now we know that AB f of x dx is the same as, if we want to split it in here, we should have something like this. From A to B, f of x, for A to C, from A to C and then C to B, dx plus C to B, f of x dx. So if you don't pay attention, you are going to circle false. But let's look at something here. This is A to C, but this is B to C. Do we have B to C here? No. So we can swap this. So this is going to give us A to B, A to C, dx. Now, when I want to swap this, it becomes negative. So this one becomes minus B to C, f of x, dx. And this one becomes true. So that's what we just need to pay attention here. We are almost done. Now let's look at this question here. We want to find the area bounded by x-axis and then the curve y is equal to this. So same idea, solve this one simultaneously. So x-axis, when you talk about x-axis is when y is equal to 0, right? And then we have another y which is equal to 4x minus x squared. So let's equate them. This is the same as this. So 4x minus x squared is equal to 0. Factor x out and have 4 minus x squared is equal to 0. X minus 0. So x will be equal to 0. 4 minus x is equal to 0. And x will be equal to 4. So the interval for integration is going to be 0, x, and 4. So remember, this is y flat like this. So this one is going to stay above and this one is going to stay below. So the area will be equal to, from 0 to 4, the function is 4x minus x squared minus 0 dx. So this is going to give us integration from 0 to 4, 4x minus x squared or dx. So integrate this and have 4x squared divided by 2 minus x cubed divided by 3 from 0 to 4. Plug in 4. This divided by this is going to give us 2. Plug in 4 and have 4 squared minus, plug in 4 to the power 3 divided by 3. When I plug in 0, I'm going to get everything to be going to 0. So let's see what we are going to get. 4 squared is 16. 4 to the power 3 is 64. 2 times 16 is 32 minus 64 over this. Solve this and have 32 over 3. Is that right? Let me check if that's right. This is going to be 90. Yeah, so that is right. That's right. 32 on 3. So that is going to give us an A here. Okay, so I'll just leave this one for you to also try. We've done some question which is of this form. So try this one and leave your answer in the comment section. We did something like this that we use the fundamental theorem to solve. So try this and leave your answer in the comment section. Let's look at the next question. If the gradient of the tangent to the curve is this, and then the curve passes through this point, then the equation of the curve is given by, So what you need to know is, this is saying that the gradient of the tangent, so it means that this is dy over dx is equal to 2x plus 1, right? And we want to find the equation. So what we just need to do is we need to find for y. And for us to find for y, we need to integrate plus 1 dx. So integrate this one with respect to x also. So this cancel this, d will cancel this, so this one will be left with y. Integrate 2x, we have this plus x plus c. And this is y is equal to 2x. No, it's going to be just x squared plus x plus c. But we need to find a constant because they've given us a point here. This point is x and y. So we have y to be 0 and we have x to be minus 3. Is that right? Yes. So 0 is equal to minus 3 squared plus, no, minus 3 plus c. This is 9 plus 9 minus 3 plus c. 0 is equal to 6 plus c, and c will be equal to minus 6. So I'll put minus 6 here and then I have it to be c. Okay, so I think all of these are correct, right? So maybe we can make one of them plus and then choose one answer here. We are almost done, left with 2 questions and then we are done. So let me leave this one for you to also do it because we've been doing this a lot. But this one, they've given you the point already. So all you just need to know here is you have the point already. So you are just going to integrate from 4 to 9, right? And then they've given you the x-axis again. So x-axis is y is equal to 0. And you have y squared, which is equal to 4x. So make y the subject and have 2 square root of x. And find the area to be from 4 to 9. Then 2 root of x minus 0. Solve this and leave your answer in the comment section. And then I think this is the last question, right? And this last question here, I think we've done it. Yeah, I think we've done this question. And then we had this one. So let me just finish the 36 and then we are done. Let me finish the 36. So this is going to give us from 4 to 9, 2x to the power 1 over 2 dx. So guess what I'm going to get from here? I'm going to have 2x plus 1 is going to give us 3 on 2 divided by 3 on 2 from 4 to 9. This is going to give us, reciprocate this, and we are going to have 4, or let me say 2 times 2 on 3. This on this, 4 to 9. This is going to give us 4 over 3 x to the power 3 on 2, 4 to 9. Plug in 4 and 9. This is 4 over 3. Plug in 9, 3 on 2, minus plug in 4, 3 on 2. And guess what are we going to get here? This is going to give us, I think 27. 27, and this is going to give us 8. So we are going to have this, and this is going to be give us 19 and 76 divided by 3. 76 divided by 3 is D. Yeah, so this is the last video on integration. Yeah, so we will end Math 102 here, and I'll see you in level 200 where we are going to talk about further calculus. So as usual, I'll see you in the next video. All the best in your exams too as well.